There we go. It's recording.
Okay. Hi, everybody. Welcome to our webinar on using LaTeX. We're going to be starting in just a couple of minutes. And until then, just get comfortable. If you haven't already done so, please make sure that you have your LaTeX editor open on your computer. And if you don't have the LaTeX editor installed, then you can go to Overleaf. Just search it on Google, and that's an online LaTeX editor. If you have any issues setting it up, just shoot a message into the chat. We'll just be waiting a minute or two more. If you haven't already, please make sure that you have your LaTeX editor open, or if you don't have a LaTeX editor, then go to Overleaf, a website that's an online LaTeX editor. And if anyone has any questions or any issues, feel free to throw them into the chat. Chat is currently disabled for attendees. There we go. Chat should be enabled now. Okay. Thank you guys all so much for coming. Welcome to the first graduate student online workshop, an introduction to LaTeX, presented by Dr. Gerhard Trippen. So today we are going to be talking about LaTeX, and this is the first in a series of workshops presented by McMaster University and the University of Waterloo's collaborative workshop team. Dr. Trippen is an associate professor in the teaching stream in the Department of Management at the University of Toronto, Mississauga, with a cross appointment to the Operations, Management, and Statistics area at the Rotman School of Management. He has used LaTeX to write his master's and PhD thesis, and as well as design slides for some of his computer science courses taught at the University of Toronto. He's going to be presenting. We are so excited to have him, and we're looking forward to this presentation. This presentation will be recorded and will be posted at the end. If you have any questions, please feel free to put them into the chat, and I'll be answering them and keeping track of that. And you can also put them into the Q&A section. So welcome and have a great time.
Thank you so much, Max. So it's great to talk about LaTeX a little bit more again. So I have not very actively used this recently, but I have used it, as you just said, to write my master's thesis, to write my PhD thesis, to write lecture notes, to publish papers. And so everything I have done was really based on searching information from the web, putting pieces together. So I've self-taught everything. And so I just wanted to share a little bit of experience with you, a few ideas how you can set up your own LaTeX files. And I hope this will be helpful. I also posted a little bit of a cheat sheet for you that you can use. And later on, if you have any questions, you're always welcome to email me. I don't know whether you have my email address yet, but we can definitely share that later. And so you're welcome to ask me questions. If I can, I will help. So there's so many things out there regarding LaTeX. I definitely cannot answer all the questions, but at least maybe I know a trick here or there so that I can help you if you have a particular question. I also would like to share my screen with you. So just to code along with you in LaTeX. And so let me see here to share this with you. The LaTeX file here, the first file here that I wanted to show you. Because I think the first thing you always do in any programming language, if you learn a new programming language, and LaTeX is a kind of programming language too, if you like so, is a hello world program. And so therefore I thought, let's go and have a look at a hello world document. So what I'm using here is the Technic Center. So maybe you have installed MikTeX on your machine. Maybe you also installed the Technic Center at the same time. Maybe you're using a different tool. So there are quite a few different tools out there to work with LaTeX documents. There's a scientific workplace, for example. So a variety of different tools, but this one here is the one I commonly used. So of course, when I started way back, so thinking back to my master's thesis or PhD thesis, it was mostly command line typing, okay, compile my file, run it, translate it into a PS file, from there into a PDF file and so forth. So running a few different commands or writing a little batch file to do this. But now we have all these nice IDEs, all these nice environments that you can use to work with. So here in this little first document, you see the basic structure of a LaTeX file. So you see we have certain types or classes of documents. So for example, you want to publish a scientific article, or you want to later on write your thesis using LaTeX, maybe a master's thesis, maybe later on a PhD thesis, or whatever it might be. Maybe you want to prepare slides with LaTeX. So you have a certain document class, in this case is an article. And we'll see this in the other example file later on, which is also online for you, the work sample that I have posted. So what you see then in there will be a lot of extra definition or a lot of additional packages that we will include. But here it's just specifying the class, and then it goes right into the document. What do you actually want to show in the document? So we have the begin document and the end document. So it looks quite like a programming language. Maybe you know the programming language Pascal. I'm a Pascal native speaker, so that was my first programming language I worked with. Nowadays, I think nobody's using this anymore, but there are also other programming languages that are using begin and end statements. So here in particular, you see begin the document and end the document, and what's really happening in between, that's something you will see in the output later. Now, if you want to run them, so depending on which environment you're using, or if you just using command line, for example, then you would have to run LaTeX now. And so here in this Technic Center, there's this command here, so where you can build the current file. So you can also create entire projects in here. So for example, for my master's thesis or my PhD thesis, my document was not just one single file, but I cut it into many different pieces. So chapter 1, 2, 3, all the way up to 7 or so, they were all in different documents. Then I had different documents for, say, like additional appendices or so, or figures and so forth. But here it's just in one single document, and you can compile this. So here, compile project or build here for the single file only, or this is also simply F7 here, or for a single file it's Control F7. So you can run this then, and if everything goes well, so then hopefully you don't get any errors here. So everything fine, everything compiled as it should be, and I'm creating a PDF output file. There are tools, like I said, that might be more advanced that you might prefer, where you even see immediately on the other side of the screen what you're typing is what you get. So what you see is what you get. So tools like these are out there too. Here, this tool in particular just creates a PDF file, and then you can go and open your PDF file in your browser or in your file system. And okay, we can probably have a look at this. If I open that, okay, so that my Hello World PDF file, I share that with you. And there's nothing surprisingly happening there. It's just a plain PDF file here, okay, with the Hello World. Okay, I hope you can see this here. So that's the output generated. So I hope this first step worked for all of you. So, or if you're stuck, so please ask questions. So make sure that you have at least the sample file running, so that as we're going through the more extensive example, that you can actually in between compile and see what you get, see what output you actually produce. So if there are any questions, so Max is very helpful and has agreed to help me here and said, okay, if any questions are out there, he would reply to them. So please go ahead. If you're stuck at this moment, maybe let us know so that we can wait a second, make sure you can actually proceed with us through the files that we're going to work on. All right. So if this all works for you, okay, then okay, we can go to the next example file, the real big example file here. Okay, so this is our sample work file that we really want to go through today. So few ideas, different mathematical formulas, say for example, tables, maybe including some figures. So let me share this with you as well. All right, here we go. And this file is here. So that is the file. I hope you can see this now. Okay, sorry here. I hope you can see this file here. And this is also the file you can download from the website for the seminar here. So this is a sample file that has been originally created by two of my colleagues. And when I started to teach these LaTeX workshops at UTM, so I added a few things, I changed a few things. So that's the original source of this file. So I should say thank you for Yael and also Sue, who originally created this. So you find their names here. So here's Sue and Yael, my colleagues at UTM in the computer science department formerly. Okay, so scrolling up back to the start of this document here. So as I said, so for LaTeX documents, we always need to specify what kind of class does this document actually belong to. So is this an article? Is this an entire book? Is this a set of slides? So this is how we always start. So we're starting by specifying a document class here. This one here in particular is an article. So you see this here, and it is an article and a particular type of article that's used by the American Mathematical Society. So an AMS article. So coming with a variety of different functionalities that we really need when we write mathematical papers. Depending on what kind of area you want to publish your articles in, So you might find particular files and packages that are really useful in that particular area. I think there are like hundreds or even if not thousands of additional packages out there. So depending on which journal you're also sending your articles to, you might have to use their particular style file, because they want to, of course, make sure that all their articles in their publications are consistent. They all need to look the same. So you would need to download their particular files, their particular style files, and then run your documents with them. So here in this example, it's this American Mathematical Society article file. And so potentially you also have to stick to a particular font size. So if these articles go into a journal, then maybe the font size might be 12 points. Yeah, so what you see here in general, so you have some, so this is something you will also see later on here, you have certain names, certain packages, and you have certain options to further specify them. And options are typically in these square brackets. So what you also probably need for your type of research, if you are working on technical topics where you have potentially theorems or where you have certain definitions that you want to highlight, or it could be also just examples if you like, so or claims that you're stating that are, well, certain theorems. So what you see down here already are theorems, lemmas, propositions, for example. So these can be potentially defined, so the style of them can be potentially defined in certain packages. So depending on what kind of packages you're using, these environments might have a particular look. So the theorem, should this be in bold font, should this be in italic font, what should be the size, and so forth. So that's also specified by what kind of article you're using and what kind of additional packages you potentially include here. So here are a few examples here, what kind of additional packages you could include. So for example, to create certain different mathematical environments, there are quite a few different packages out there. Or maybe if you have particular ideas how you want to set up tables or more advanced tables where certain, say, names or entries in the tables go over multiple rows or potentially over multiple columns, then ways of including figures, different types of figures. So like I said, there are many, many different packages out there that you might then want to include. And the nice thing about the typical environments that you can work with, like for example, Technic Center, if there are packages that you have not downloaded yet, that you haven't installed yet, this will typically run automatically. So as we're trying to translate this, as we're trying to compile, the environment will figure out, oh, I can't find this package, so let's just download it on the fly. Because as I said, there are just many, many packages out there, and it's impossible to install all of them in advance. And well, you just go along as you feel, there's something I need, there's something useful for me, I want to add this to my document, I want to use this kind of package. Then you install it as you go along. Similar to certain programming languages. You might be programming in Python, right? So you're installing additional packages then. Then, as I said, so we have particular environments. So say, for example, theorems or lemmas or propositions. And so these can then later on be called through their particular names. So you can later on say, I want to, well, now state a certain theorem or a certain claim here. And what name should actually occur or appear in the output here, that's what you're defining here. And then all the theorems and propositions and examples and figures and so forth, they can be counted. So that's a very beautiful feature of LaTeX. So all the counting of figures, lemmas, example can be done automatically. And when you're referring to these figures and theorems and so forth, you don't have to worry about, oh, now I added another lemma up here, and now my counting is messed up. No, LaTeX, after running the document, will update all these numbers, all these counts automatically. So you can also then specify which counter should be used. And depending on the style of the article or your thesis that you're going to write, so you could, for example, say, well, everything should be counted, just count through, just kind of like 1, 2, 3, 4, and so forth, no matter what it is. Or you might say, well, I'm numbering my theorems independently from my examples and independently from my propositions, for example. So it might lead sometimes to confusion, but maybe that's the style that you want to use. You want to say, here's theorem 1, 2, 3, 4, and then there are some lemmas here, 1.2 and 1.3 and 1.7, and so forth. So it depends on potentially the journal you're publishing in. It depends on the requirements of your master's thesis that you're writing. It depends on maybe your own style, what you feel is most suitable. So there are a variety of counters available for you that you can use to then number these kind of theorems. You can also additionally create, say, additional environments, like for definitions, for example, or remarks or examples, and you specify how should they look like. Well, they should also look like theorems. That's what these two or these few lines or those two blocks here specify. Then, yeah, how do you number equations? So you might just say, I'm just going to number my equations through from 1 to 20, whatever my equations are. Or maybe you say, I additionally want to have a prefix. So I want to say, this is equation 1 in section 7, and this is equation 2 in section 7, and so forth. So you can have equation numbers like 7.1, 7.2, and so forth. Overall, this means there is a lot you can predefine how this later on should look like. So all these kind of numberings and referring to theorems, referring to figures, referring to equations, that will be automated in LaTeX. And that's something very beautiful. So there's nothing like, oh, I added another figure here. Now I have to renumber all my figures, have to change my index of figures, have to change my table of contents and whatever. That's not there in LaTeX, and that's the beauty, and that's what I found really, really useful when I was writing my PhD thesis. So I had a few different papers that went into the PhD thesis. They all had their own numbering originally as their standalone papers, but now just integrating them into my thesis was very easy because all the counting was just done automatically by LaTeX. Everything was just updated, just because LaTeX will help you with this. So that's one of the key points why I still like to use LaTeX also for other documents. So for example, when I submitted my review package, I also did it all in LaTeX. I said, I'm not going to Word and then start to move things around and renumber things and so forth. Although I think Word has caught up with this a little bit as well. But well, I had done all this in LaTeX and just thought, well, it's very useful. And so I'm going to continue using it. What you can also do, which is also very helpful as you go along when you're writing your articles, is defining your own commands. So for example, say you want to show the set of real numbers. So you have real numbers, and for that you want to use some kind of special symbol, maybe an R that's like outlined or something like this. So, or you have complex numbers and you want to use also some kind of like outlined or bold C, or you have some calligraphy A. So you have a special set. So you're talking about elements in a particular set A, and for that you don't want to use some standard A, but you want to have some nice calligraphy A. So writing this out every time when you're referring to, say, the complex numbers or the set A, or writing out every time a fraction of 1/2 can be a little bit tedious. And you can, well, simplify this very easily by defining your own commands. So whenever I want to refer to the real numbers, which would be written out here, for example, as this command here, so this math v here, R, I'm just going to say \R. So what you notice here as you look at this, all these commands here are starting with the \. So this is also how the definition itself starts. So to have a command starting with a \, and this command defines something, namely it defines this R here. So therefore the command itself will be \R as, well, whatever is in these curly braces here. So that's another very neat feature. So in my PhD thesis, I even used this for certain expressions, so for certain words. So for example, I had to write all the time, strongly connected directed graph or something like this. So, and then I just said like, okay, I don't want to write this out like this. I just like use a short command. Okay, so, and then say, wherever I put the short command, I will have strongly connected directed graph. So this is another very nice feature. So, and if there's anything you want to change later on, so if you say, well, I don't really like how this A looks like, and I rather have a different kind of A, and well, then you can just change whatever's in this command here, and then everywhere in the text, you have that new A or whatever. If you have to rename it and say, oh, the set shouldn't be called A, it should be called B. So it's very easy to change this as well. Another very powerful idea that's integrated into LaTeX. You can go a step further with this. So you can also say, well, I want to not just define these kind of constants, but I even want to go a step further and want to add an additional optional parameter in such a definition. So here you say like, okay, give me something here additionally. So give me something in here, in such an expression that is variable. So this is really given as an optional parameter that you put in there. So I say here, this is, for example, a fraction, so showing like a partial derivative. And I say like, yeah, so which variable with respect to which variable do we want to calculate this derivative? And then you can say, well, for example, x or y or x1 or x2 or whatever it is in your particular context. So another very powerful idea in LaTeX that you can have these kind of definitions, these kind of commands that we have, and they can even take parameters and accordingly make your life much, much easier. So this one here now concludes the kind of definitions that I have here. So you see, I included a few packages here. I have something about theorems and propositions and claims. I have a little bit of like, how do I do the numbering? I also have a few special constants here, creating some shortcuts for me, and then some more advanced ones. But this is the kind of setup that I want to use throughout my document. So this preamble, if you want to call it like this, can actually be also much longer. So depending on what you really need, depending on what kind of packages you want to include, what kind of extra options you want to set, and so forth. So depending on really what you need, you can put a lot of different things in there. Potentially even it's so much that you put this into an extra file. So, but this is now all we have here in the header. And so now, after this header, we're coming to the actual document. So again, as we have seen in our Hello World example, we're going to start with begin document. And so we can now also define a title of this document. And again, so depending on how you're using this later on, so whether it's an article or some particular thesis or book or whatever, this title here, so what you define here as title, will then be formatted accordingly. So if it's an article, it might be just on the first page on the top, and then there will be more on the same page. Or if it's a book, maybe this will be on the first page, but there will be nothing else on the same page, and so forth. So this process will be all automated depending on what kind of documents or what document class you will be using. In the title itself, we have then simply an example of a LaTeX document. And note here, we actually have here a command. So this command LaTeX here. So this makes sure that LaTeX is formatted just accordingly. What's the standard formatting of LaTeX? So how should this actually look like? So you can see the effect if you look at the PDF document. If you compile this later, if you try out, then you can see how it's formatted. There are also several authors listed here. And so depending on which journal you're going to publish your article, for example, these authors might be listed maybe right under the title. Maybe they will be listed somewhere in the bottom. Maybe they will be listed one under the other one, or they will be listed next to each other. So that depends a little bit on the journals themselves. So how do they look at the formatting of the articles that you publish in the journal? So you don't have to worry about this. So you say, I can try to publish in this journal or that journal. I don't care really. I just have to define the authors and state their email addresses, also their addresses. So here we only have one address here. At the time when we were teaching these LaTeX workshops earlier, we were all in the computer science department or math and computer science department at UTM. So we have a Sue with her email address, Yael, and her email address, and me here. So here you have my email address in case you want to contact me later on. So this is my email address, okay? So this is how you specify those. And so potentially you can also add some other additional footnote. In this context here, they're called thanks. Okay, so here, in fact, this is a thanks. So we said, okay, we thank UTM for the opportunity to deliver this course. Or here, okay, I'm now going to add or copy something here maybe. So, and maybe I should say, okay, I thank Max to deliver this course. Okay, so this is how we easily can, okay, for the opportunity to deliver this course. Okay, all right, something like this. Okay, so I have another thanks here. So this is the title. The title each will then be generated, as I said, depending on what kind of document class we have. And then potentially, so depending on what your type of document, what's the type of document that you're using here, you might also need an abstract. So a short summary of your paper. So a short introduction, what's the scenario? So what did you find in your paper, some short conclusions or something, just a kind of like a summary of your paper, so a short abstract. And if you read journal articles, then you will see there are many, many different ways of formatting the abstract again. So again, you don't have to worry about this. So you just say, okay, here's my abstract. Okay, so format it however you like it, whatever you need. What's the style of your journal? So, but here, this is my abstract. And then make title will then take care of all this and put the title nicely together. So processing the title, the authors and everything, and puts it all together potentially onto this same title page. You can also now add table of contents. Where you add them, this is up to you. So potentially they will be in the beginning, potentially they will be on their own pages in the beginning of the book. Maybe they will be at the end of the book. So besides table of contents here, you can also add things like list of figures and also maybe an index. So those are additional pieces of information you might want to add. So here, for simplicity, I've just added this table of contents. And again, for the table of contents, you can also specify a lot of different things. So how should it actually look like? How do you want this formatted? So what kind of indentation do you want there potentially? Also, how deep should we count? So should we really give just the chapter numbers? Chapter 1 is this, chapter 2 this, or should we give chapters and sections, or then even chapter, section, subsection, and so forth. So you can give a depth parameter. So how much detail do you actually want to see in that table of contents? So that's what you're setting here with this counter. So just to give you an idea, in LaTeX, there are quite a few different things possible. So you just have to figure out how are they actually implemented. So just maybe Google, search around a little bit, and definitely somebody else has had such a question before, has done something like this before, and you will find a way that looks like what you need for your own particular paper or your own thesis, say, for example. So lots of different things are out there, lots of different kind of classes and files. In fact, so something that I can also share with you later or briefly show you later. So there are entire thesis classes out there. So you can download a package and just modify it for your purposes. Maybe you have to change a little bit, make a few little adjustments, but for my own PhD thesis, this was very useful. So I simply took an existing package and just modified it to the specific requirements of my university, just made a few changes in the file so that it just looked like according to what I needed for my university. But it's good to go with a starter package rather than doing everything from scratch. And there are quite a few useful things out there. So that's about the table of contents. And then we have here the introduction. So here's a section. So this one here, once more, is just an article. So an article has sections and subsections and sub-subsections if you want to. So a book would also have chapters. Okay, so articles don't have chapters, so there's a little bit of adjustment potentially necessary if you're moving a paper into your thesis or so, or the other way around. So here for the article, like I said, we just have a section. So here's a section introduction, and then we have a subsection, a definition test. And this is something so you can now try out to complete. We can work on this a little bit together. So I thought we are now going to have a look at the definitions that we created up here and maybe use some of them. Maybe let's type a little bit and try out. So to use them, so what you see here, these are all, well, mathematical expressions here. So my entire article here is really about math mostly. So, and what I need therefore is a kind of math environment. So I need to tell LaTeX, this is actually something that I want to be formatted as beautiful looking math. And so a very simple way of creating such a math environment is to use these double dollar signs. So a single dollar sign also creates a kind of math environment, so a math display, but it's in the same line within the text. So where you're typing the text, LaTeX will try to put the mathematical expressions in there too. If you want to have a kind of like standalone view of the mathematical formulas, like it's centered in its own box, if you like, then you're using these double dollar signs. Okay. And now within this math environment here, you can try out a few of those commands. So for example, the real numbers or the complex numbers here. So you can put a few of those, or this A in this calligraphy font there, a different font. So any kind of definitions that we saw up there, you can now try out. So what else did we have here? We had, for example, an overline. We had like a small set minus. We had a fraction, which was 1/2. The epsilon here, and maybe an inverse, things like this. And here also the partial derivative. We should try this out too. So try out a few things. So put some things in there. So say, for example, the overline here we had, or say, for example, we had created this fraction of 1/2. Okay. And then we also had like this partial derivative, for example. So you can try out a variety of different things. So this was the command we had used here was dd. And now here there's this parameter that we can pass in here additionally. So that's the beauty of this new command, which takes the parameter here and say, for example, that should be the partial derivative with respect to x. Okay, so and then we're closing this math environment again with this double dollar signs. So you can now run this. Okay, so here in this environment here, I would press Control F7. Okay, so fill in a few things, run this, okay. And zips. Okay, so here, sometimes when you run this, so you get potentially some warnings. So warnings can come from, for example, changes that you have implemented in the document and certain things have been shifted back. And so now the links that you have created, they are not referring to the correct page anymore, because now everything is one page later. So now these things might have to be updated. So, or where certain sections are starting in your document, suddenly your second section starts at page 4 instead of page 3 and so forth. So these are the kind of warnings that you often get. And then you can rerun this. So depending on what kind of warning this is, whether it's really something significant, or whether it's really just a warning because things have shifted. So these warnings will simply disappear after another run. Because LaTeX creates in between additional files where it keeps track of additional information, so where certain things are, where they start, and so forth. And so after rerunning this, these files will be updated, but not yet used in the newest version. So it takes like a run or two until everything is updated, everything goes fine. if you're looking at this one here, this is the example document here. So I can show you this one too. So let me just unshare this for a second here. Okay, so this is how this would look like in this example here. So you have the LaTeX document here, also the special formatting of LaTeX that I mentioned earlier. You have the authors here, for example. In this particular article style, you see, for example, the email addresses are not listed, nor is the mailing address listed here. So it depends on the style file, as I said before. Here's the abstract, and here's our table of contents, which has been created automatically. So I'll also give you a few other links and pointers a little bit as I go further. Here's an example. Okay, I think I opened the other document, the other original document that I had earlier. But what I just implemented, what you have maybe also just implemented, are the real numbers, maybe the complex numbers, some kind of set A, maybe the fraction 1/2, and then the partial derivative. So that's something maybe that you have in your document as well. Okay, so I hope you're all able to get output like this. I hope this works for you. All right, and let me share, okay, my text document with you again. So this is here. Yeah, all right. Sorry, here we go. So this was just a little bit of a test. So how can we use those definitions? How can we actually set this up easily? And how does it actually look like in the PDF document? So after this first little definition test here as a subsection, we're coming to the next subsection. So maybe the real introduction here now after this little test here. And so here I'm just stating once more what's our goal. Well, we just want to show a few different ideas when it comes to using LaTeX. And so play around with it. Yeah, read online if you're searching for anything particular. Maybe send me an email as well if you're maybe stuck somewhere. So I'm happy to help you with this as well. So, but there is a lot of information online as well. So just play around and try what you get. Sometimes, I know I've also experienced it's not super easy. Sometimes you might be a little bit stuck, but eventually you will find a way to really format it all nicely. And you get a very nice, beautiful product in the end. That's definitely sure. So a little quote here. So if you have anything like quotes or examples or claims, so once more, then this can be formatted through any particular environments. So once more, so it's not about like formatting by yourself, what you would maybe do in Word, where you say like, okay, this one here should be a quote. So I have to make it cursive and I want to maybe increase the font size a little bit, or I want to center it and I want to make it stand alone within the text. So all these things that you would do manually in a Word document, and you would have to do it for every quote that you then fit into the text, so to make it consistent. All these things will be taken care of by LaTeX for you. So I'm just going to wrap my quote here into that quotation environment here. So begin quotation, end quotation, and whatever quotation is formatted like, that will then really be the look of this quotation itself. So if it's in the middle somewhere centered by itself, if it's italics or whatever, that will be the formatting. That's the nice thing about these environments. That's also a nice thing about what we had seen earlier, the theorem, the proposition, and so forth. They all will look the same. There's no formatting necessary. You don't have to increase the font size manually. You don't have to make it bold. You just say, this is a theorem. So it will always be font size 14. It will always be bold. That's the beauty of LaTeX. It will take care of that for you. You can also easily if you just by yourself want to make things italic, or maybe you want to have something in bold, then of course there are also commands for this. So you say here, I want to emphasize, so which means this is in italics, or I want to put it in bolds. So you say the text BF here. These would be the commands to highlight text in italics or bold font. There are also ways to skip lines. So when it comes to formatting, so sometimes it can be a little tricky. So LaTeX has its own idea how it's going to format everything. So you see also here, I broke down everything here in individual lines. Maybe make sure it's not too wide, the text here. Make sure I can see it on a relatively small screen, or maybe next to each other if you have two files next to each other. So I have my own formatting here. But LaTeX is going to ignore this formatting completely. So LaTeX says, well, this one here is some continuous text here. So I will put this all together as continuous text. The same thing is true for spaces. So if you just want to put spaces in here, like I do this one here, then LaTeX will just say, well, for whatever reason, you put spaces there, but of course, this is not meaningful. So when I put this together and when I print this out in my PDF document, these spaces will all be gone. So LaTeX is doing its own formatting. So it's saying like, okay, this is just a text how you write it, but I try to make a beautiful document out of that. So sometimes you have to trick LaTeX a little bit, and you have to say, well, but I do want to have some extra line here. I do want to add some additional space here. I want to have space between those words for whatever reason. So then, as I said, you have to trick LaTeX a little bit. And so, for example, with this backslash here, you're going to skip a line, or with these ones here, or those commands here, you can add additional space into the texts. So you can force LaTeX and say, okay, I want more space between these words for some reason. I want it to be like this. So, and to avoid LaTeX, so to prevent LaTeX from reformatting that for you to make it nicely evenly spaced, well, you have to put these commands in there to explicitly state, I want to stretch it out. So that's the purpose of such commands, of these single backslashes here. So to just add some additional space here, so to add more in between. And another thing you might notice as you're writing the text, LaTeX puts a little bit larger space after a full stop. So LaTeX says like, okay, the sentence ends here. So let's help the reader a little bit and say, okay, pause here after the full stop at the end of the sentence. So it creates a little bit larger space. But maybe for some abbreviations, or maybe if you do not like to put a comma behind this E.G. well, then LaTeX would think this one here would be the end of the sentence and it would create a larger space. But you don't want this, so therefore you can put this backslash here to really make sure you just want that single space here in between. So, or what you can of course also do is you can put this E.G. What I typically do, I say comma. Okay, so I put a comma behind this, and the space that LaTeX creates after the comma is by far not as large as the space that comes after a full stop. Okay, so I believe there should be an E.G. comma. Okay, that's how I would personally format this. Okay, that's a little bit about spacing and the maybe related issues with this. So sometimes this makes it maybe a little bit more complicated, or maybe makes it you to think about it or to get used to it. But so LaTeX is trying to optimize the spacing. There's something you might also experience if you add figures to your article. So LaTeX has certain ideas how many figures should be on a single page and how much space on a single page should be reserved for figures. So sometimes you have to trick a little bit there too to make sure that you get those two figures onto the same page if you really want so. LaTeX thinks, oh, this is too much, so you shouldn't have too many figures on a single page. There should be a significant amount of text and then a figure. But sometimes you might say, but I want more figures on that page. So you have to trick a little bit there too. There are particular commands also how you can change certain options on how much space to reserve for what. But that goes a little bit too much into detail right now. All right, so let's go on to the next section here. the next section is on formulas and math symbols. And this section here, what you see, so this may be something new here, this also gets a label. So here I have a label, and I call that label section, and then formulas. The label is really up to you. But if you're labeling a lot of objects in your document, so if you're labeling figures and tables, and you're labeling sections, and you're labeling equations, and so forth, well, then maybe you want to use some kind of consistent way in which you're creating these labels. So, because you might have a figure which has the same label as the section itself, but you want to have two different labels, really, one referring to the section and the other one to the figure in that section. So you might say section formulas and then like figure formulas, something like this, just for your own naming of these labels. And so in this section of formulas and math symbols, so as I mentioned earlier already, so we're using these single dollar signs so that we have the equation in the text. So for example, you see here, there's a dollar or dollar. So this R will then be presented in a mathematical font. Or if we're looking here at the 2 pi R here for the circumference of the circle here. So that will then be shown in a mathematical font. So, and you see here, pi is simply a command in LaTeX. So you're using the backslash here, and then you're simply writing pi. And that's true for most of the Greek letters. So as you speak them, you just write them there. So you say, for example, for the mean, for the population mean, mu, for example, you just write backslash u. So mu. So we simply write and create these mathematical symbols in Greek letters. And I think, at least personally, I think it's much faster if you get used to this. It's much faster to type out these formulas and get beautiful results than using some kind of equation editor where you have to rearrange things and put them here and there and so forth. And it takes a long time until everything is finally there where you want it. So at least I got used to this LaTeX style here, and I just type out my formula, and just like a few minutes later, or depending on the complexity of the formulas, so it could be also just a few seconds later, I have my beautiful formula. So you can also compare what happens if you're using these mathematical symbols or not. So once more here, if you're looking at this, putting it into math symbols here, putting it into the dollar signs gives us a kind of like cursive font. So this means also if you want to add text into the math environment, then again, we have to trick a little bit, because putting the dollar signs around really means all what's in here should be math. So please try to format as math. So we can have a look at this document here. So if I quickly switch over here and show you some of these outputs here, then we can see what LaTeX actually creates here when you do this. So let me switch over here for a second again and show you the output. Okay. So again, so here we have the formulas, okay? And so what we were just talking about, and then we will move on to the next one. So what we were just talking about was, for example, this radius R here, or the circumference of 2 pi R. Or when you're looking, for example, this one in dollar signs and this one not. So this is regular text, but this is formatted like maybe a function, okay? Or maybe a variable name. So whatever this might be in your particular context. And what we're going to do next, okay, that's something we want to try out now. So are these, well, somewhat more complex formulas. And this is really where the beauty comes in, and I don't think any other tool can create formulas as beautiful as LaTeX. So this is where I really love it for. You really get very, very nice output. Sometimes maybe you want to tweak a little bit with some extra space or something, but all these things here, so where you get something here to the power of something, to the power of something, well, these double ones and whatever here and there and counters here. So this is something that LaTeX can do very, very well. All right, so let's go back to our sample file and try to create these kind of beautiful equations together. So I hope you can see my tech output again. So what we would like to do here as a first step here is using these double dollar signs to create these kind of beautiful equations. And then we want to see, well, how can we quite easily actually create them? So how can we create such a sum? Okay. So the first one said here, I'm summing up the first n natural numbers. So, and I wanted to sum this up, simply write this into a formula. Okay. So, and that's what we would like to do. Okay. That's what we would like to write here in the document. I said to complete. So once more, the key point here is now to use the double dollar signs. So they give us these individual equations in a centered form, individual, so separated from the text that we have surrounding it. And so it was just like 1 plus, okay, and if I switch over here once more quickly, it was just, so 1 plus, and then was dot, 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 plus n is equal to the sum, and that's the way the summation sign there, from k is equal to 1 to n of those k's, so the first n natural numbers here. So in LaTeX, we would write so 1 plus, and then instead of writing something like dot, 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 LaTeX actually has something more advanced to make it, again, look more beautiful. So it has something like dots. So it has commands for a different variety of dots. So it has, for example, those lower dots. So the way you just say, okay, 1 plus and dot, 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 which you want to have at the bottom, plus dot, dot, dot. Or it has also centered dots. It also has diagonal dots. It also has vertical dots. So there are all kinds of different dots that you can also use, for example, in matrices. So if you're doing a lot of linear algebra or you have matrices in other contexts, so there are quite a few different types of dots out there which make it look better than trying to put your own dots there. Okay, so we have the L dots here, for example, and then you're going all the way up to N. Okay. So this would be our sum here of the first n natural numbers. And then, so we're going to say, well, make that, so give me a summation sign here. And so for the summation sign, we now have to say what's our counter, where we start, and what's our upper limit. So to use subscripts and in general, we're using the underscore. So we're going to say here the sum from, so which is underneath the summation sign, or if you're putting it into the same line as the text, so if it's using like a single dollar sign here, well, then it would be actually putting it right next to the summation sign, but as a subscript. Okay, so at the lower bottom here as a subscript. So if we're using the double dollar sign here, the math environment, then we get a more beautiful visualization of the summation, and we get it actually below the summation sign. So we said from, and for example, using k here as a counter, so we have our k is equal to 1. So in the curly braces, we put in here what is down here in the subscript, and then the superscript, so in this case, what goes on top of the summation sign here, this would be simply our n, right? And because this is just one single symbol, so it's just this variable n here, we don't have to put this into curly braces. Of course, you can always do this if you feel like this improves the readability, then just put this into curly braces as well. So it might also help you later if you want to make any changes here. So if this is a different counter, if this is a more complex counter, maybe you want to put this into curly braces too. And then you want to add up those k's, okay? So if you want a full stop, so if you feel like, oh, this is the equation and my sentence ends with this equation here, so then you actually have to put that full stop into the math environment. So if it helps you to separate this for yourself for readability, maybe put it here. Okay, but of course you can also put it here, or you can put it here. LaTeX does not worry and does not care really about your formatting, because it will put that full stop wherever it thinks it's supposed to be, so that it's close to that equation there. Okay, and then you're closing this with the double dollar sign again. Okay, so that would be an example of the sum of the first n natural numbers here, and how you write this using the summation sign. I hope this makes sense. Okay. So here I have another little piece to complete. Okay, so the next example here. So what we were briefly looking ahead was a little bit more complex. So there were different pieces in there. Maybe I can share this with you, can share it once more with you so that you have an idea what was in there. So we will have two different things in there. So one of them was a product. Okay, so here we go. So here we have n factorial. So what is n factorial? How is this defined? Well, this is the sum here from k is equal to 1 to n of these n first natural numbers. And then here we have some integral. Okay. So, and I will put these two here. They're not this one block of math. And so I still want this end here to be like regular text. So I wanted to give you an example how you can do this even though you're in this math environment here. Once more, what you see here, so what I also mentioned before, this is like the full stop here, or here there might be another full stop added on. So let's have a look how we can do this. I think for this one here, you should be easily able to do this by yourselves, in fact, so you can try this out. So as I'm talking, you can try and go ahead. How could I do this? So this symbol itself, so this capital pi, so this product here that we're calculating, will simply prod. Okay, like for this summation sign, it was simply sum. So this capital sigma here is just sum, and this capital pi here, so this product symbol here, so it's simply prod. Okay, let's try this. Okay, and share my other sample work file again. All right, so here we go. So we have here again, let's use this math in mind here. So as an individual math block here, so we have the n factorial here we said. So n factorial is equal to, so we said this is the product, sorry, the product. And then again, we have here a counter, right? So we're going from k is equal to 1 all the way up to n. So that's our upper limit of this product. And what do we multiply here? Okay, so it's all these k's, right? From k is equal to 1 up to n. So then we said, well, we want to put more into that same math environment. And again, we talked about spacing and that you sometimes have to trick a little bit to convince LaTeX that you have some extra spacing there, that you need some extra spacing. So for example, we force LaTeX to create some space here. Okay, so this depends on you, how much space you want, okay? And we said everything that's in this text, in this environment, is formatted in a kind of math font. So typically like this italic font, because we're talking about variables, we're talking about certain special symbols. So, but I actually want to have regular text. So we actually have to tell LaTeX, well, then make it text again, because this and should be in the regular text font. And then let's get a little bit more space after it, okay? And so now we're going to implement our nice integral here. So, and the integral here, okay, so for this, you will also find the command in LaTeX. Okay, so this int, it's your integral. And so then you say like the lower bound here was 0 and the upper bound was infinity. Okay, so for this, we also have a special LaTeX command. So this is this inft. Okay, that's infinity. All right, and then, well, you can, depending on whatever this integral was here, so looking back, something like r times, okay, and then the exponential function here. So we had to the power of, and then it was like minus r squared, right? So looking back at my screen here over, yeah, so e to the minus r squared. So this means, so this to the power, okay, so we're using the superscript. And there are a few things in the superscript here. So I'm putting the curly parentheses around here and say negative, okay? And then we have R, okay, squared, okay? And so dr, okay? So this is equal to, okay, and so now when you were looking at this, well, so you saw there was like this kind of like imbalance there. There was this vertical line which indicates this area from 0 to infinity, right? So after the integration there to calculate this. So, and what you can do, or what you do in LaTeX here is like saying there is something on the left-hand side and the right-hand side, maybe curly braces or maybe big parentheses, but sometimes you don't have anything on either side. So I will show you another example later. For example, a case environment where you really only have one curly brace on the left-hand side of the case environment. So and there's this missing curly brace on the right-hand side. So you want to omit this. And so therefore, to omit the corresponding curly brace or the corresponding vertical line or the corresponding square bracket or whatever it might be that you're using in a particular context, you can just say, well, there is nothing on the left-hand side here. So you say, sorry, this is a command here. So you say left and say simply dot. So there is nothing. A dot just means like, maybe if you like a little space, okay? So, but just like omitting, there's no corresponding object on that side of your mathematical expression. And then here we have the fraction here. So you could just say, well, half if you like, okay? Because we had created this special command here, half, okay? Or if you like, you could also write out once more as practice and say, this is a fraction in the numerator of 1. And in the denominator, you have 2. Okay, so this is really all this. For a fraction command, you always give the numerator, and then you give the denominator. So either of those two you could use. Okay, so now with this, we have our 1/2 of this fraction. And so what's next? So let me quickly look at the output here in my document. So it's e to the minus r squared. Okay, again. Okay, so e to the power of, so then you have in the exponent minus r squared. Okay. Okay, squared again. All right. And then as we had seen in the output briefly, as we had discussed here, so on the right hand side, okay. And so as a subscript, because we said the interval goes from 0 to infinity, right? So subscript is 0 again, and then the superscript is again infinity. Okay, so, and okay, if you want to, you can conclude all this with a full stop again. Okay, and that closes our math environment. So it takes a little bit of practice. It takes a little bit of learning what are the different commands there, how do we put this together. But after some practice, it becomes very easy. So it's just much easier to write it out, and you get some very beautifully formatted formulas. And so you just have to learn a few special commands. So learn how to set up these equations, what's going in there, what are superscripts, what are subscripts, how do you put this together. But then it's pretty easy to type them out. It's also nice if you have a sequence of equations. So step by step, so doing some transformations or whatever. And so you say, okay, here I'm just like replacing A by B or whatever. Out multiplying this or whatever, and go step by step through the calculations, through some derivation. Then you can very easily copy this and just make the adjustments as you go along. Or if you have to plug in some numbers into some functions, for example. All right, so this one here, okay, just to show you once more how this would look like in the PDF file. So this is what we had done here. Okay, so this one here. this integral here, and this product here. So you can also pretty easily create these kind of things here. So some of them are potentially standard LaTeX. So something that's already built into LaTeX. Some other things like this one here, for example, we say here, this is for x to infinity. This is something I want to put underneath this arrow here. Well, then potentially this is not in standard LaTeX. This is maybe something you have seen in some particular journal papers, or this is something maybe you need for, well, for example, the American Mathematical Society. They want to format it like this rather than formatting like this, potentially. So it depends. So not everything is possible with just basic LaTeX. Not everything is implemented in the way that you can get all possible outputs. But there are a lot of different packages around, like I said, like this package here, AMSCD, so where you can create a few different kinds of graphs even. So you can have even, let's say, like 4 different corners and connect them with arrows. So maybe some cycles or whatever it could be. And well, so you have to just load this package. So use package here in LaTeX, and then you can create some other kind of figures that you cannot create with the standard LaTeX. All right, let's go over to our LaTeX file to have a look at how these things could be implemented. So once more, so we wanted to have this limit here. Okay, so let me delete this one here. Let me delete this one here too. And in this case here, so you have the limit here. So put this into a math environment again and say here our limit. Okay, so what do we want? So what we set x to infinity. So x, okay. So we're saying here 2, okay, inf t, okay. That's how let's write this here. And then we'll say, okay, this is what goes under the limit sign, okay. So, and then we have the f of x, okay. Okay, I think this was just a very basic example here. Okay. All right. Yes, that was just it. Okay, so here's the comma. As I said, you can also move this over a little bit, but LaTeX will reformat this for you. All right, so this would be basic plain LaTeX as it comes. Okay, so you can get a display like this. But, okay, so if you want to have this other kind of view where this x to infinity was below the arrow there, then, well, standard LaTeX might not be able to do this for you. So, but therefore you can include other packages. And one of them here, as I said earlier, so scrolling up a little bit, was this one here, okay? So the AMSCD, for example. Okay, so that one, if you are looking at this, if you're Googling this one, then you will also find something. I can also open that for you here and show you this very briefly. Okay, so let me share this screen here with you. Okay, so this is here. Okay, so you can create some more advanced mathematical figures here. Okay, so there are a few examples here. So of these kind of graphs that you're creating there, equivalences or certain transformations. Okay. And typically able to find quite a few of these examples if you just Google, if you just search online. And typically you will also find these examples with the corresponding LaTeX code next to it. And then you can just start to modify it and change this according to what you need. So for our particular example, so our example was much simpler. So our example here, okay, let's go back here and scroll this down where we were. Okay, so sorry, this was here. Okay, so copying this, so basically looking at this and the way in which we had this just seen in the examples here. So this would be this environment here in this math the AMSCD package here, and then we have the f of x. Okay, and then the special symbol that was used here. Okay, so this add here in the particular syntax in this particular package here, and then, okay, x. And then what we had to put, so below, so is x to infinity again. All right. Okay, and the formatting here required then another error here, and then a 1. Okay, and that ends this command here, this particular CD environment here. So this is just a basic example. So just showing you there are many, many more options than what standard LaTeX provides. There are many, many packages out there that can help you to create much more complex figures. If there's a little bit time left at the end, though, I can also show you a nice tool. So from another former colleague of mine, Ottfried Chang, and he wrote a tool which is called IPE. And with IPE, you can also create very nice figures, including LaTeX code on the figures. So including these kind of labels. So you don't even have to have these packages that create these figures for you, but you can actually just draw them. Okay, and just put the LaTeX code right onto the figures. So maybe there's a little bit of time that I can show you something of this. Right, but these were a few examples on these kind of like equations. So this is the main power of LaTeX, I think, and all its packages that we have. So really creating these kind of figures, making this much, much easier just by writing a little bit of code, being able to create very beautiful figures. Make them very nice looking, so it's automatically formatted. Don't have to worry about it. You can change a little bit of spacing if you want to, but they're typically very nice. Okay, so outperforming lots of what you typically get from other tools, equation editors that you might be using. All right, so then here, just a few other things. So a few different ideas. So because main thing, as I said, are really these beautiful equations here. But here are a few other ideas. So once more, you can create these kind of like environments, like for theorems or so. And so if you create these environments, and if you're using different style files, then these theorems will just look exactly like you need them. So if you are publishing a paper here or there, they have their own view how theorems should be looking like, whether they should be bold, at least the title, whether they should be numbered, or whether there should be a letter in front of them, whether the text of the theorem itself should be bold or cursive or just like straight text, whatever it might be. So you don't have to worry about it. You just write your theorem and wrap it into the theorem. So begin theorem and end theorem. Similarly then also the proof of a theorem. So again, the formatting of the proof, so how all this text is formatted in the end, this might then depend on the journal, whatever kind of article class they are using. And if you're using a theorem like this and a proof like this, so don't know exactly which field you are in, but so for some of the fields like theoretical computer science, where I'm originally from, you have this square at the bottom, this QED, right? So when you finish the proof. So this will be also generated automatically. That can then also change in its shape. Could be like a solid square or just a blank white square or something like this. So whatever it might be, this proof environment will take care of this as well. Okay, so here are some more examples. So in fact, so this is then an example. So the example begins and ends, and you put something into the example. And then you have also definitions. So here once more, when you're writing the definition, and you want to refer to that definition later on, you can also label that definition. So then this definition has a label, and in the text you can then refer to it. You can say, as we have seen in definition 7.2, well, and that label, if you put that label there, that will then put the 7.2 into your text. Okay, so in the definition itself, you just see a few other examples. Once more, here you have the italic text here, so the emphasis here. You also see once more here how to create Greek letters. So as I said before, so for Greek letters, you just put the math environment here, so the single dollar signs, and just write out the name of the Greek letter. So an alpha here, for example. So here, maybe if you look very carefully, then you see there is a little tilde in here. So right between the 2 and the alpha. So a tilde is really a space, okay? So if you would write, like, for example, as another example here, you say like doctor, okay? And then you have a name, okay? And so what LaTeX would say, well, there's a full stop here. So I should make a little bit of space. Okay, so we talked about this earlier, how you could potentially avoid a space with a backslash. So, or, well, here, this does not work with a comma, right? Because obviously there should not be a comma in there. But another thing that works is this tilde in between here. So a tilde is invisible. It will not be seen in the output here. So, but it just says, well, don't create a large space in here. Just put a normal, a regular space between the full stop here, or the dot here, in fact, and the name. And so this can be used also, so this kind of like a regular space, to try to keep things together. So if you think about this definition here, and you think about, well, here you have like maybe the alpha by itself in the next line. Well, that would look a little bit weird in the definition. And this might happen based on the formatting, based on how wide the page is, and what you get. And I say, well, at least I want to have 2 alpha in that same line. And so you would put the tilde in between, and then LaTeX will try to keep these elements together. So you can try this out. You can try compile this, try out a few tildes here and there, and see how LaTeX will try to keep these components together in the same line. So this will look much better if it says at least 2 alpha than just having alpha hanging just by itself in the next line. Okay, so also these names here, they don't matter at all. So here I just call this hocus pocus, but actually if you move up again, then you will see, well, a hocus pocus is, well, maybe it was actually a preposition. Okay, so actually it's a proposition. So you can name this whatever you want to name this. Okay, so whatever name you want to use in LaTeX itself. But these are the names that will actually be printed in your output. Okay, so here, for example, the proposition here, I don't want to write this out every time I have a proposition. I'll just say prop. Okay, that's much easier. So that's the idea once more. Okay, so just making our life easier, simplifying a few things, shortening things for us. So that's once more what you see here. So prop, and by the way, there was a star on this prop, and the star typically means, so you can use this for theorems, you can use this for figures, you can use this for tables, for example. But the star generally means do not number this. Okay, so don't give a number to that particular prop here. Okay, so we talked about this one already. So this was about labels. So we have these labels, so section labels, for example, or we had created a label for that definition. So now we can refer to that label here. And so we can just say ref root. Okay, so this was the definition 7.1, for example. So therefore it will just then say here, well, this is definition 7.1. And again, I would like to keep definition and 7.1 together as one. So therefore I put that little tilde here in between, as we have just seen that before. Okay. Or you say, okay, I want to refer to a different section of my article. So you just say, for example, this section is section, and then you say like section cross. Okay, so this was a label that we had used before. And then here you just refer to that label once more to refer to that cross. Okay, so a few other ideas here that are definitely very helpful if you're writing articles or if you are writing your thesis with LaTeX. So all these references here will be created automatically. So, and when you run this in LaTeX, you might get some warnings in between, because you made changes, section numbers have changed, table of contents has changed, page numbers have changed. So you will get these warnings and say, okay, there's something that's not quite updated yet. And then as you run this multiple times, then you should be down to 0 warnings again, typically. Okay, but even if you don't get down to 0 warnings, so don't worry too much about the warnings. Sometimes it's something a little bit more tricky where a figure goes slightly out of the boundary or something like this. So I had these things already before, and then I just said, okay, fine, the figure is going slightly over. I don't worry too much about it. So let's just keep going. So I just left the warning as it is. So, all right, so there are some remarks, okay. So, and once more, so similar to what we've seen for sections or definitions, for example, you can also, of course, create labels for equations. So there are, in fact, here equation environments out there, which support you further to format these equations even more nicely. So where you have potentially also multi-row equations, and you want the equality signs nicely aligned, right? So for that, you would use an equation environment. I have this, I believe, also on the LaTeX cheat sheet, so which you can also find on your website. Okay, so equation array, for example. So if I stop sharing this here for a second and share this with you. Okay, so here, cheat sheet that I posted for you. Try again. Okay, here it is, I think. Okay, so here are a few interesting commands. Okay, so for example, here, there are, of course, also these special symbols in LaTeX that we've seen, for example. In particular, we've talked about the $sign so far. We can talk about these ones here in the following briefly too. So the $signs, if you actually want to get a $sign, well, then you would use \$ also for some other special symbols. But then how to wrap variables into mathematical fonts, superscripts and subscripts and so forth. But what I wanted to show you at this moment, just briefly, is that equation array here. Okay, so the equation array here with the, well, formatting here with the nice alignment of the equality or inequality signs here, or whatever you might have in your series of transformations. Okay, so there are nice packages, nice environments out there that can help you to really make that look very pretty in the end. Okay, so then you can also at any time in the doc add footnotes here. Okay, so you can put citations in here as well. So you can, I have not done this here in this document, but you can create even entire collections of references. So one tool that I have used, for example, is called JabRef. So it's a little Java tool, I think it has been written in Java, and allows you to collect all kinds of paper that you might be interested in citing, or does have some relationship to your paper or to your research that you're doing. So and you just feed in all the citations into this tool, potentially then extract subsets from this tool, or you can just, well, use your huge database of papers that you potentially want to cite and, well, refer to some of them, and then it will just draw out the corresponding references to put together your bibliography. So I haven't done this here in much detail. I kind of like hard-coded the bibliography in this particular example here, but there are better ways of doing this. So in a sense of just maybe create your database, and then you can use these references in many different papers. You just have to give me the link here, and then it will just include this in the end of your document. Okay, so this is how you would do a citation. Also here, the style of your citations depends on what kind of bibliography style file you're using. And this might depend very much on the journal you want to publish your article in. So depending on where you're going to publish, you might have to use a different style. There are many different styles. Do you just want to use numbers in square brackets? Or do you want to use something like author and year in curly or round parentheses or something like this? Even the references in the end of your document how do you format them? Is this just like first letter of the first name dot last name, or is it just last name, last name, last name, year, or something like this? So there are many, many different formats there. And you don't really have to worry about these formats, because once you have that style file, that will create your bibliography exactly how you need it for your particular article in this particular journal. So you just have your database where the set extracted from. Okay, so this is a citation here. This is a footnote here as an example. Okay, so you can also change the footnote size, for example. So there, as I said, for many of the things that you have here, there are additional options. So where you can make adjustments. If you think this is a little bit too small, you don't like this font, or you want to have more spacing or things like this. So many, many things can be changed, can be adjusted to make it look like you exactly want it. But the question is, do you really need this? Well, what does the journal need? The journal typically has their own style files, and they potentially send them to you, that you can run your file directly on their style files so that you see how it will look like later when it is published. Okay, so here just a few more examples. So a few basics. So for example, creating lists. So I just want to give you one simple list example here that we can do together. And then, and then there are more list examples here that we can go to. So here, I want to do this one here. So let's create a list that is enumerated. Okay, so where we're numbering the items. So again, like a programming language here, we're starting with the begin, and then we enumerate. Okay, so depending on what kind of tool you're using, you might have seen this. So here, this MikTeX Center here, Work Center here, also supports you a little bit here, the Technic Center, to give you a hint how this command might look like. So you have to begin enumerate, then you have an item, the first item that you want to list in this enumeration. So say like A, and then you have like another item here. Okay, so like B for shortness. I'm not going to write out a lot here. I just showed a brief example here. Maybe say like C. Okay, so you can put anything else in there, and then you can say, okay, and enumerate. Okay. Right, then I have here again, like I said earlier, the spacing is something that LaTeX decides by itself. So you might not be always happy with the spacing, and you might feel like, oh, so there's this list here, and then I have another list right below this, and somehow they're too close together. I want a little bit more space. Like, as I said, there are different tools or a variety of different commands out there that will help you to create some space. So here, for example, you can add a big skip, so which is creating more space in between. All right. So this one here would be an enumeration, so first, second, third. But if you don't want to enumerate, if you just say, well, I have here a list of items and I don't want to add a number here, then you can simply say itemize, okay? So like a bulleted list. Okay, so you have multiple items in there. The list can also be nested into another list. So you see here, within this item in the list here, you have another itemize here. So you have a list, a bulleted list nested into the other list. Maybe to show you this for a second. Okay, so to see some output here, let's go back here. All right, so let's move down here. So we had seen those. Okay, and we're now talking about the lists here. Okay, so this is now here what I showed you here, the enumerated list here. So you have 1, 2, 3, and this one here is the itemized list here. Okay, so you have the dotted here for the outer list, or for the nested one here, you have the hyphens. So this means here you have either enumerations here, or simply these items here in this bullet list, if you like, bullet points. You can also, again, as with many other things, make adjustments to how they should look like. Do you want numbers here? Do you want to have like 1 dot, 2 dot, 3 dot? do you want to have something like Roman numbers maybe? So I, so 1, 2, 3 in Roman numbers. So all this can be changed. So you just accordingly, again, make adjustments. So you just set some specifications. What kind of numbering do we want? So then accordingly, you just set this as an option for the enumeration, and then the list changes accordingly how it looks like. All right. Let me show you another example here. Okay, let me share this with you again here. Go back here, share my screen of the LaTeX file, source code. Okay, so this was all itemized here. So other things that might be interesting to you, so maybe case environments or maybe matrices. So there are, for example, these array environments for matrices. But before going there, maybe I show you also a case environment. So this is maybe the last thing or so we can complete together. So let's see. So how would we, for example, define the absolute value of x, right? So this would be a basic example. So we'll put that so in the basic, okay, basic LaTeX. There are also, again, more advanced tools and packages out there to make it look maybe even more advanced or more suitable for what you in particular would like to show. But this is just here like pretty basic. So I'm going to use the absolute value here. And how are we going to define this absolute value of x? So you can use this begin cases. All right, sorry, curly brace here to close this. And then, so we have to list the individual cases. And there you will see now, I mentioned this very briefly on the cheat sheet, LaTeX cheat sheet, that there are some other special symbols that are being used. And that's something also that you see here when you look a little bit ahead. So what you see here, and I'll try to align this a little bit here just for readability for myself. So you're going to say here, the case is here x. And so the absolute value of x is x. Well, in which case is this? Well, if x is, then we can use, again, a special math symbol. So you don't have to type anything like this one or so. So there are symbols for this. There are special, you can look this up in the math cheat sheet. There are special commands for this. So it says greater or equal than, oops, this was greater or equal to, greater than or equal to, okay, so 0, okay, 0. Okay, and that concludes this first case. And so we have to tell LaTeX, okay, this is where the line ends. That's where this case ends. So we conclude this with this double backslash. And then we have the case here. So we have the minus x here. Okay, so we're going to change the sign. Well, if our x is, well, negative, right? All right. So these are the two cases we have. Either it's just x if x is greater than or equal to 0, or, well, we have to change the sign if it's negative. So, and with this, we're going to end the cases. Okay, so we have end cases. All right, and this ends our math environment. So similar to what you have seen here, so you see this ampersand in here. So this ampersand is a kind of like column delimiter. So you want to have multiple columns here. You can think of this as an array here. So on the x and the negative x here, there are in this first column, if you like. And, well, the description of the case itself is in the second column. And we put the ampersand in between to delimit the columns. And this is also something you see in matrices or arrays or tables. So you see here, you have a very basic 3 by 3 matrix. So, and so the by here, by the way, so the symbol or the command for this in LaTeX is times. So 3 times 3 matrix. So, and what you see here is that this matrix T here, okay, so this is a 3 by 3 matrix. You see this in here. There are 9 fields, 9 elements in here. So in the first row of the matrix, you have A, B, and C. So they're in the column 1, 2, and 3. So the individual columns are separated by the ampersand. And this double backslash once more indicates that you're going into the next line of the matrix. So you're going to row 2 and so forth. What you also see here is this left and then square bracket. Using this left, as we had seen this earlier, a little bit earlier, this will ensure that this square bracket itself has the right size for the matrix. So if you just put a square bracket by itself, then you might just get a small square bracket, just kind of like imagine in front of the row of the matrix, so somewhere in the middle. But putting this into a left square bracket makes sure that the square bracket really goes over all the rows on the left side. Similarly, for the right square bracket, you're closing the matrix on the right side with this right and then square bracket. Okay, so this is how you're setting up matrices or tables. So they just erase basically here. The CCC, by the way, here means that all these values here are centered within each column. So you can align them to the right or to the left or center them. So here they're centered. This table, or this matrix here, if you like, does not have any lines anywhere. Okay, so no horizontal or vertical lines. So therefore, if you want to have some, say, like tables where you do have lines, well, then you can do this. And so here you have a pretty, so you have an example here first, and you have a pretty advanced example down here. So I copied this here from the wiki books about tables. So you see like there are even entries here that are going over multiple rows or potentially also over multiple columns. So it takes a little bit of effort, a little bit of tricking until you get the table really set up in the way you like. But so once more, so if you do want to show you first a simpler example, if you do want lines or maybe also double lines in between, then you would simply put, if you want a vertical line, would simply put a vertical line up here with we're specifying the alignment of the individual columns. So here a single line between, here maybe a double line, maybe here again, the table is concluded at the left end with another line there. So, or if you want lines in between, so if you want the horizontal lines between individual rows, well, then you're simply going to say H line. And so this simply creates a horizontal line in your table after this particular row here. Okay, so if you want to, you can try out also a very basic example. So basic example without any lines. So if you want to really do this very quickly, so you can just copy this here and say, well, let's create a very basic example without any lines. So here we have maybe basic formatting here, left formatted, centered. So let's do this again here, centered, maybe right. Yeah, so there are no lines in between the columns, but there are no lines between the individual rows either. So I'm getting rid of the H lines here too. So you can compile this and you can look at the difference. So you can then see this one here has no lines in between anywhere, while this one has. So, and as I said, this one on here, so the other example that I showed you here, this is much more complex because you have not just a basic table where you can imagine the alignment is perfect like in a matrix, each cell has its own values, but actually you are merging individual cells together. So you're, for example, saying, oh, this particular word here should span over 4 rows. Or you're saying other words, for example, should span over that many columns. So the team here, that should span over multiple columns. If you want to see the output, that takes a bit more effort to create this. If you want to see how this then looks like in the end, let me share this with you briefly. Okay, so this is my output file here, the PDF file. So then you get something like this. So the team sheet here itself, this kind of title of the table, if you like, then spans over all 3 columns here. While, for example, defenders here spans over those 4 rows here. So this is where this multi-row and multi-column comes in. So this specific package that really allows you to create these kind of tables if necessary. So we're seeing the code is a little bit more complex. Let me share the other screen with you again. Okay, so here you have the code again. Here once more, you see this multi-row here, for example, spanning over 4 rows, or here you see the multi-column, for example, spanning over 3 columns. In between here, so as we were talking about the tables, I have some other like ideas or just like a quick comment additionally. So this one here, actually LaTeX code. This is a command, so use package multi-row. Or this one here, this is also a command, multi-column, okay, and then some parameters here. So if you want to include text into your document, which you don't want to evaluate, so you just want to keep it as it is, and you don't want LaTeX to do any reformatting or any kind of evaluation, then you can wrap this into verbatim, okay? So you just say, take it as it is, take it literally. So don't make any changes. I just want whatever it is. I just want to print it as it is. There also, if you like to include, I don't have an example of this one here in this file, but thinking about verbatim or thinking about special formatting of text and keeping it this way or that way, there are also special code environments. So if you, for example, want to include Python code into your LaTeX document, so you could use this environment here, or there are special code environments. So maybe code environments that highlight like certain keywords of the language, or code environments that have additional line numbers and things like this. So that might be more helpful, depending on the purpose, depending on what you need, might be more helpful than just putting it here as just basic plain text, untouched as it is. So it might look better, it might be more suitable, depending on the purpose for which you would like to use this. So the last really big picture here, the last big section maybe, is like figures. So figures that you create potentially with any other tool, maybe even that are screenshots, or maybe that are maybe photos that you want to include. So depending on your research, depending on what you really need. So all kinds of figures can be essentially included into your documents. So you have this kind of figure environment, which ensures that the figures also are labeled, that the figures are listed, for example, in an index for figures, if you like. So here you see the figure should occur here, and the exclamation mark says like, yeah, try to really put it here, okay? So there are different ways how figures can be aligned. I mentioned this very early on, that LaTeX is not always happy with where you want to put the figures, but it wants to put the figures where itself wants to put the figures. So you might not be happy with LaTeX is doing with you. So you can try to force LaTeX to put it at a particular position, or try to convince or push LaTeX to do that. But it's not always guaranteed. So like I said, you have to be a little bit careful where these things really end up in the end. So depending on how large your figures are, maybe you also want to rescale them a little bit, so make them a little bit smaller until you really feel like, yeah, if I make it small enough, it fits nicely here into the text where it is. Then you can import quite a few different formats, for example, PNG format or other formats. EPS was typically a standard a while back, but you can also include JPEGs, or you can also include other PDFs. So that was, for example, something I did when I had to include a lot of documents into a bigger document, which themselves were PDF files. So that's also possible. So, and like I said, a caption, you might also give a label and so forth. So, and this figure itself, if you really look at this, so look at the output, then you get this one here. So let's have a look at this figure. So we're back here. So the figure itself, so I purposely chose this kind of figure. So the figure itself is not quite pretty, right? So, and if you really look very carefully, then you see, oh yeah, very jaggy lines. And so you cannot really zoom in here. And so it's really obviously created with, say, like some, I don't know, paint tool or whatever. Okay, so it doesn't scale nicely at all or whatever. So this here is really like an example how in the end it should not look like. Also these disconnected lines here not attaching nicely to the nodes and so far and so forth. So I wanted to show you this figure here as a motivation to convince you to use obviously a better drawing tool. And one drawing tool that I can recommend at this moment is maybe IPE. So if I can show briefly too. So like a whole introduction to IPE, but there's so much out there and has been improved a lot. So, but I can just go briefly here for you. So here's IPE. Okay, so and in this document, what you see here, what I loaded here was actually not a figure, but what I opened here is actually the LaTeX cheat sheet. So you can create entire documents or also in IPE. So, but of course, creating documents in IPE might be a bit more tedious because you have to create your own text boxes. So, and then align them also by yourself. So you are responsible for the formatting, how this data looks like. But everything in here, so in these text boxes, can be including LaTeX code. So again, here, this is LaTeX, it says LaTeX cheat sheet here. And so if you edit the text here, then you see what I actually used here was kind of like LaTeX code. So I didn't use the LaTeX command here, but I just like tried myself and just like did some formatting myself. So I put this here into a math environment here and have like here this superscript and this subscript here and created math. Okay, so these math symbols here, creating this math environment in the text that you see here. So also all these ones here, see on the right-hand side. So these are all based on text, and all these texts here, they are, sorry, this was the same. So all these texts here, again, they are LaTeX code. So everything here in this figure, okay, so here, if you look at this, okay, table, as we've just discussed this here. So a table with 2 columns, and so you see the lines in between, the horizontal lines. And so there's the verbatim here, the verb here for short on the right-hand side, because this is how the command looks like in LaTeX. And on the left-hand side, so once more, you're seeing then the ampersand in between to separate the 2 columns here. So here, for example, okay? So you see then the LaTeX code itself, which then, when you run this, so is translated into the LaTeX output. So you have the figure directly with its LaTeX code attached to the figure. So I remember quite a while back, people kind of like drew figures using some tool. I think I also, when I first started to use this, I used a tool, I think it was called Xfig. So you could create pretty nice LaTeX figures, but you were not able to have LaTeX in that same figure. So you had to additionally then position LaTeX on the figure. So at least in some early versions of some of these tools. So you were not able to have LaTeX directly on the figure together with the figure. Here in this tool here in IPE, you can create your figures together with the LaTeX code and compile it. You can save them in different formats. So there's a native IPE format, which is just an XML file, or you can also then save it as a PDF file, or also as a JPEG file or PNG file or whatever. So, or what people typically have used previously, like an EPS file, and then you can very easily include this into your paper. Okay, so as a, going back to the other example here, let me share this with you again. So this is about figures, okay? So, and then here, conclusions, okay, potentially conclusions don't have a number. And then finally, the bibliography. So once more with the bibliography. So here it's kind of hard-coded into this document. But if you're writing a thesis, it might be making much more sense that you have some kind of database that includes all these kind of potential items that you want to include. And then you create a bibliography just by saying by the bibliography is here. And then because you have all these citations in your text, they will then be automatically put into the bibliography. To show you such a document, which you might be interested in using, so for your own thesis, say for example, your master's thesis. So here is an example package. Let me just open that for you and share this with you. But that's just one particular one. There are many others like these. Okay, so here, for example, so what I have used, I think, as a kind of template for my own PhD thesis. So here's this package here, writing PhD thesis in LaTeX. And so it really basically gives you all the ideas how you can put all the pieces together with different chapters, how you're numbering the chapters, how you're putting figures and equations in, how you're putting the different chapters together. So potentially also into individual files, potentially into different directories. You can, so also besides like appendices that you put in there, you can, and references that you put in there, you can also additionally have like an index, for example, maybe a list of figures, maybe a list of tables, and well, maybe the table of contents as well. So there are many things that will then be automated and put together based on just like all the labels and the references, all these things that we have talked about, and just puts the whole document together. Everything is numbered perfectly. It also creates this index here for you in the PDF file. So it's a pretty powerful tool and makes things really much easier. When I think I would have to create this using so like Word or so, it would be pretty scary for me to make that switch. Maybe it's quite easy nowadays too, but I would still prefer to stick with LaTeX. Okay, so I think I have covered everything I wanted more or less in detail. Some of the things I, of course, had to go over a bit more quickly, but I've also given you a few additional pointers on what other tools you potentially could use. So one other thing maybe I can show you just as a last example. So let me just switch over to that too. So just maybe this one here. And let me share this with you. So this one here. So if you want to create slides, so maybe PowerPoint, of course, or maybe LaTeX instead. So some people use the Beamer package, but what I actually have done is I use actually IPE. So just a tool that I showed you that you can use as a drawing tool. So IPE has a pretty neat function that allows you to add layers to each individual page. So, and if I go through this, these slides here, so those are slides from about like 8 years ago here for computer science course. So then you can layer by layer show content of the slide. So this is one page in the IPE document, but this page has say like 4 different layers, and different parts of the page only appear on a particular layer. The nice thing of this is, of course, that you don't have to, well, have like 4 individual slides for the same thing. So, but you really only have one slide. And you can, in fact, export this whole thing as just having always the final slide. So if you want to share these documents with your audience, then you can, excuse me, you can export it always with the complete slide. So without the individual layers in between. So what you can also put in there are like kind of like animations. So it's not truly animated, like say like in a PowerPoint animation, but you can put figures where you have more and more added to the figure. So where you're cutting pieces out here, like in this binary search, for example, where you're extending the figure layer by layer. And again, so the nice thing is that you really have one figure here, and each box occurs in its own layer. And if you imagine in a Beamer presentation, for example, you exported like 5 different figures showing how this like changes from step to step. Now you have to make a change. Well, then you have to export those same 5 figures again. But here, this 32 really only appears on this very first layer, and then it goes through all the individual layers. So if 32 was wrong and supposed to be 30 instead, well, you just change it, and then it will be 30 on all other layers too, because 30, this value sits on that very first layer. So you can create these kind of animations relatively nicely. And so thinking of like looking at recursion trees, for example. So if you want to visualize them, so let me just go forward to one such slide. So here's like a recursion tree and another recursion tree here. So you can build this up step by step without having to export many, many different figures into some kind of other document. It's all living in that same document. It's one PDF file. So I can directly save it into this one PDF file. And this PDF file here can be opened by IPE again. Of course, IPE cannot open any arbitrary PDF file, but if you have created a PDF file with IPE, then you can share it as a PDF file, and IPE can also open it again, and you can make further modifications. All right, I think this is really the last example that I wanted to go through. So thank you very much for listening to me. Hope you got some few ideas. And I think there were lots of chat messages in between too, which I didn't read in between, but I guess Max, I turned over to you.
All right. Yes, I was looking over the chat. Thank you so much, Dr. Trippin, for that fantastic presentation. This is part of a collaboration workshop series presented by the McMaster Engineering Graduate Society and the Graduate Student Associations of McMaster University, the University of Waterloo. And we're adding in Western Society of Graduate Students. Our objective is to take advantage of this difficult situation that we're all in right now and share some good skills for graduate students. And 2 weeks from now, we're going to be having a presentation on mental health in grad school with a professional from Toronto, and we're really excited about that. So today's presentation will be available as a recording on our website, GSA-UW.ca/workshops, as well as a bunch of the examples that have been posted and discussed here today. And if you have any further questions, please feel free to email us. Our contact information is available there. Thank you all so much for coming. Stay safe, and thank you again, Dr. Trippin, for that fantastic presentation.
Thank you for having me. Thank you very much. It was my pleasure. Okay, have a good day and stay safe and healthy.